Useful to represent preferences numerically. This is going to allow us to use the mathematical tools that we're accustomed to. Typically what we're going to want to do is associate indifference curves that run through more preferred bundles with a higher number than indifference curves that run through less preferred bundles. We're going to call these numbers utility. So the number associated with the given bundle, or with the indifference curve that passes through a given bundle, is the utility that you get from that bundle. So a utility function is typically going to be represented by the letter u, and u of x is the utility that you get from bundle x. So for some bundle A, comprised of Q1 units of pizza and beer, u of A is the utility that the consumer gets from consuming that much pizza and beer. So this utility function is an alternative way of representing a consumer's preferences. So one example of a utility function is a Cobb-Douglas utility function. And this is something we're going to use a lot, so you'll want to get familiar with this concept. So the utility that the consumer gets from Q1 units of good 1 and Q2 units of good 2 is Q1 to the A times Q2 to the 1 minus A for some A between 0 and 1. So these Cobb-Douglas have some very nice properties, and so we'll see these a lot. So let's suppose for simplicity A were a half. So utility from Q1, Q2 would be Q1 to the half times Q2 to the half. So it's Q1 to the A, which is a half, Q2 to the 1 minus A, which is 1 minus a half, which is a half. Of course, this is just going to be the square root of Q1 times Q2. Now, which bundle is better? Bundle A, which consists of 16 units of good 1 and 9 units of good 2, or bundle B, which is comprised of 13 units of both? Well, we can now very easily answer that question from this utility representation to the consumer's preferences. The utility that the consumer gets from the first bundle, which is the square root of 16 times 9, which is 12, is less than the utility that the consumer gets from the second bundle, which is the square root of 13 times 13, which is just 13. In other words, the bundle 1313 is better than the bundle 16-9. So whenever we have u of A bigger than u of B, this means that the consumer prefers A to B. Whenever the u of A equals u of B, then the consumer is indifferent between A and B. It's important to note that these utility numbers are only meant for ordering the bundles. So if you have a bundle A that gives you utility 10, and you have a bundle B that gives you utility 20, does it mean that you prefer bundle B 10 more than A, or that you prefer bundle B twice as much as bundle A? No, it doesn't mean that. A utility function only lets us order things, right? So just a higher number means that you prefer it to something that's associated with a lower number. And it really doesn't say anything about the strength of preferences. Well, you got to be very careful with that. So let's say you prefer bundle X to bundle Y. Then what we know is that u of X is going to be higher than u of Y. So u is a description of your preferences. Now let's suppose u of X is 5 and u of Y is 4. So we know that X is better than Y. But now let's suppose I just said, I'm going to create a new utility function, u tilde, where I'm just going to double all the numbers. So then again, we're going to find that u tilde of X is going to be higher than u tilde of Y. So you're still, even if your preference were your utility function were u tilde rather than u, you would still prefer X to Y. In fact, any pair of bundles such that you prefer X to Y when your utility is given by u, you're going to prefer when your utility is given by u tilde, because you're just doubling the numbers. Right? So u and u tilde describe exactly the same underlying preferences. In other words, you can have many different utility functions that represent the same exact preferences. So let's get into this a little bit more. So take some utility function u that corresponds to the preferences given by this thing. So I'm going to explain to you how there are infinitely many other utility functions that also represent the same exact preferences. So what we're going to do is we're going to take some arbitrary function. Take any function f that's an increasing function. What do I mean by increasing? I just mean that if x is bigger than y, so take any numbers x and y. If x is a bigger number than y, then f of x is a bigger number than f of y. Then start with the function u and define some new utility function v. So the utility you get from q1, q2 is just, to get that, according to this utility function v, go to this old utility function u, find the number that u associates with the bundle q1, q2, and then pass that number to the function f. That defines a new utility function v. Now v is going to define exactly the same preferences as u. In other words, whenever the bundle x is better than y according to u, the bundle x is going to be better than y according to v, and vice versa. So the ordering of the bundles is going to be exactly the same under u and under v. And the reason that ordering is preserved is because f is increasing. Whenever x is bigger than y, f of x is bigger than y. So f preserves the ordering of x and y. So let's take an example of this to make things clear. Let's take this particular form of an increasing function, where a is a positive number and a doesn't have to be positive, but b is positive. So then, according to our definition on the last slide, v of q1, q2 would just be a plus b times u of q1, q2. Well, if u of q1, q2 is bigger than u of q1 prime, q2 prime, so if we have two bundles, x is q1, q2, and y is q1 prime, q2 prime, and x is better than y, then you're going to have u of x is bigger than u of y, which is this. U of q1, q2 is bigger than u of q1 prime, q2 prime. But then if we have a positive number b, remember I told you b is greater than 0. So if I multiply both sides of this inequality by b, I maintain the direction of the inequality. Now if I add some constant a to both sides, it doesn't change the sign of the inequality. But this thing is just v of q1, q2. This is v of q1 prime, q2 prime. So v of q1 prime, q2 prime is smaller than v of q1, q2 if and only if u gives them the same relation. In other words, v and u order the bundles exactly the same way.